this is Akila from Computer Science Engineering in specialization of AI and ML. Today's my topic is N jobs through M missions. First, what is N jobs through M missions? Convert the problem into two mission problems and then solve by using the Johnson's algorithm. Here we have 5 steps. First one, find the minimum of M1 and minimum of M and maximum of M2, M3 and so on, M minus 1, where capital M is last mission. And the second step, check whether minimum of M1 greater than or equals to maximum of Mj, where j is equals to 2, 3 and so on, M minus 1, or minimum of mm is greater than or equals to maximum of mj. Here we have a third step. If the inequalities in step 2 are not satisfied, the method for otherwise go to the next step. Here we have a fourth step. In addition to this step 2, if m2 plus m3 and so on, m minus 1 is c is equals to c. Here where c is the positive constant for all I is equals to 1, 2 and so on n. Then determine the optimal sequence for n jobs, where two missions m1 and mm by using the optimal sequence algorithm. Here we have a final step. If the condition m2 plus m3 and so on m minus 1 is not equals to c, we define two missions g and h such that g is equals to m1 plus m2 plus m minus 1 and h is equals to m2 plus m3 and so on mm. Then we determine the optimal sequence by using the Johnson's algorithm. First we have a problem. 5 jobs are to be processed on 4 missions. The processing time for each job on each mission is given as below. Determine the sequence of the jobs that minimizes the total elapsed time into complete the jobs. Here we have a table. Jobs are A, B, C, D, E, F, and we have a M1, 9, 11, 7, 14, 15. Here we have a M2 mission, 2, 1, 3, 4, and M3, 4, 5, 3, 6, 2, and we have a mission 4, 13, 6, 11, 7, 9. For that problem we have a solution. Minimum of m1 is equals to 7 and minimum of m2 is 1 and the maximum of m3 is 6 and maximum of m4 is 13. Now we have to convert this problem into two missions g and h such that g is equals to m1 plus m2 plus m3 and here the h is equals to m2 plus m3 plus m4. We have a job sequencing A, B, C, D, E, F. For that G 15, 17, 13, 20, 21 and H 19, 12, 17, 13, 15. For that we have a job sequencing C, A, E, D, B. Here the job sequencing M1, M2, M3, M4. For that we have a job sequencing C, A, E, D, B. First M1 mission in, out. In 0 and out 0 plus 7 is equals to 7. And 7, 16 for E, 16, 31 for D, 31, 45 for B, 45, 56. And for mission 2 in and out for C 7, 10 and for A 16, 18 for E 31, 35 for D, 45, 45 for B, 56 and 57. For mission 3, we have a in and out. For C, 10, 13. For A, 18, 22. For E, 35, 37. For D, 45, 51. And finally B, 57, 62. For and fourth mission, we have a in and out. C, for C, 13, 24. For E, 24, 37. For E, 37, 46. For D, 51, 58. For B, 62, 68. Here we have a total elapsed time is equals to 68. M1 is equals to 68 minus 56, that is equals to 12. M2 is equals to 68 minus 10 is equals to 58. Here we have M3 is equals to 68 minus 20, that is equals to 48. And M4 is equals to 68 minus 45, that is equals to 23. And finally, thank you. Thanks for giving this opportunity.